Hello. Yes, we welcome you back to PSSB with me, Richard here. Yes, tonight we're looking at this question. It says, covalent bonds can be categorized into polar or non-polar covalent bonds. Then the question comes, is meant by polar covalent bond. So polar covalent bond is the bond between two atoms of different electronegativities, leading to unequal distribution of electron density between the two atoms. Yeah, that is that. Okay, the examples we can have is hydrogen chloride. So when you look at hydrogen chloride, what do we see? We are having hydrogen bonded to a chlorine atom. So this bond we are talking about here is polar. Okay? Because chlorine is more electronegative compared to hydrogen. So there is an equal distribution of electron density. Electron will tend to stay more close to chlorine, which is electronegative. Yeah, then we come to this question. It says, what is meant by non-polar covalent bond? What is it? Non-polar covalent bond is a covalent bond between two identical atoms, which means that they have the same electronegativity. That one leads to equal distribution of electron density between the two atoms. Yeah, that is it. And the example we can give here is hydrogen molecule. Okay, when you look at hydrogen molecule, you realize that it is hydrogen bonded to hydrogen. And these two atoms are the same, they're identical. They have the same electronegativity. So under that circumstance, our covalent bond, our two pair of electrons are lying in the middle. They are equally distributed between the two atoms. Yeah. Then comes this question. It says that the bonds between atoms can be categorized as shown in the table. Okay, what we have here is the difference in electronegativity. On this side, we have the type of covalent bond. So it's if the difference is 0, the bond is non-polar. 0 to 1 is weak polar. Then 1.1 to 2 is a strong polar. And greater than 2.1 is ionic. Okay? Then the question says, determine the type of each of the following bond. Right, non-polar, weak polar, strong polar, or ionic. Okay, the first one is the bond between H and F. Okay? How do we go about that? Okay, you need to know that to determine the nature of this bond, we calculate the difference in electronegativity. Okay? And for hydrogen, the electronegativity is 2.1. Meanwhile, for fluorine, it is 4.0. So what is the difference? Yeah. The difference is 1.9. And 1.9 falls in this category 1.0 to 2. So what can we say? It is a strongly polar. Okay. Yeah. Then we come to this one. The bond between sodium and chlorine, which exists in sodium chloride. Okay. How do you determine the nature of the bond? We find the electronegativity difference. For sodium, it is 0.9, and for chlorine, it is 3.1. So this gives us our electronegativity difference as 2.2. And 2.2 belongs to which? To the last one, which is greater than 2.1. That means that the bond is ionic. Then the next one is this one, the bond between a hydrogen atom and another hydrogen atom. What do? We find a difference in electronegativity. For hydrogen, it's 2.1 minus 2.1, giving you 0. So 0 belongs to what category? It's nonpolar. Yeah, next one is this one, between magnesium and oxygen. So when you find the electronegativity difference, for magnesium, it's 1.2. So minus 3.5. What you get out of here is the difference in electronegativity. So we get 2.3. Now 2.3 belongs to which category? It belongs to this last one, because this one is greater than 2.1. And what is it? It is ionic. Yeah, then next we come to this one, the bond between nitrogen and oxygen. Okay, so we find the electronegativity difference. And for nitrogen, it is 3.0. And for oxygen, it is 3.5. So giving us 0.5. Now 0.5 belongs to which category? It belongs to this range between 0 and 1. And what is it? It is weak polar or weakly polar. And with that, I would like to say thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. We appreciate your time. We urge you to subscribe, to comment, to like, to share. And we need to remind you that this channel specializes in physical sciences grade 12, 11, and 10, and natural sciences grade 8 and 9. We recommend that if you are using the channel, use our well-arranged and organized playlist. For grade 8 and 9, just look for natural sciences grade 8 or natural sciences grade 9. For grade 11 and 10, look for physical sciences grade 11 and physical sciences grade 10. As for grade 12, each chapter is presented independently. Just click on the chapter of your choice, and then you'll have all the material which you need for that course. With that, I would like to say thank you. Stay blessed. See you next time. Bye-bye.